Dependency Injection. Have you ever built code that worked perfectly until you tried to change one tiny thing and everything broke? Welcome to the world before dependency injection. In this video, we'll explore how dependency injection makes our code flexible, testable, and clean. We'll start with a bad example. Fix it step by step using inversion of control. Apply the dependency inversion principle and finish with the best way to inject dependencies. Constructor injection. Let's start with messy code. This order processor creates its own notification service every time. It works, but it's tightly coupled, hard to test, and painful to change. Every method repeats the same dependency creation. If we ever change how notifications work, say from email to SMS, we'd have to edit every method, process order, cancel order, and notify delay. That's not scalable. Inversion of control, or IOC, flips the responsibility. Instead of creating its own dependencies, the class receives them from outside. Now, order processor no longer decides how to create notification service. It just uses whatever instance is given. That's inversion of control. The dependency inversion principle. The D in solid says high-level modules shouldn't depend on low-level modules. Both should depend on abstractions. Now, order processor depends on the interface iNotification service, not on the concrete class. We can swap email for SMS or WhatsApp. No code change inside order processor. A simple way to inject dependencies is function injection, passing them as parameters to each method. It's fine for one-off methods, but quickly gets messy when many methods need the same dependency. Every method now takes the same dependency repeatedly. It clutters method signatures and makes the class harder to use. Constructor injection fixes this neatly. Constructor injection solves the repetition problem. We inject the dependency once during construction. All methods can reuse it cleanly. Now the dependency is injected once and reused by all methods. We had used this in our DIP example earlier too. In tests, we can inject a mock. In production, an IOC container wires everything automatically. Now let's see why dependency injection truly shines. Imagine we want to send order notifications, sometimes by email, sometimes by SMS, or even WhatsApp. Without DI, we'd probably add more if or switch statements inside our order processor, right? That's messy, and every new channel means editing existing code. With dependency injection, we don't touch the order processor at all. We simply inject a different notifier, email notifier, SMS notifier, or WhatsApp notifier. The order processor doesn't care how notifications are sent. It just calls send. That's the beauty of DI. We can extend behavior endlessly without breaking what's already working. Our high-level logic stays clean, and our code becomes flexible, testable, and future-proof. A car depends on an engine, but it doesn't build the engine itself. The engine is injected into the car when it's assembled. This means we can swap a petrol engine for an electric one without redesigning the car. That's exactly how dependency injection works in code. Plug in new behavior without breaking old design. Let's recap. 1. IOC inverts object creation. 2. Deep ensures we depend on interfaces, not implementations. 3. Function injection works for single use cases. 4. Constructor injection is best for long-lived dependencies. 5. Dependency injection makes your system flexible, testable, and future-proof. 6. Inject. Don't create. I'm Ashish Kumar. Thanks for watching. Dependency injection isn't just a coding trick. It's a mindset. It helps us write software that welcomes change instead of breaking under it. So next time you create a class, ask yourself, should I build this dependency or inject it? That's how clean code begins.